Assalamualaikum warahmatullahi wabarakatuh, and good day. My name is Mohd Hafizi bin Zohari. This is instrumentation and control system, MME 6114, one of the elective subject for master coursework under Faculty of Mechanical and Automotive Engineering Technology, University Malaysia Pahang. Let me go straight to the course outcome for the subject, which is we have 4 course outcome. So this is the thing that we expect the student can achieve by the end of the semester, especially for the subject. The first is develop. The student should be able to develop an understanding on advanced concept of measurement and instrumentation. And the second one is we expect the student can design a virtual instrumentation system for data acquisition and signal analysis. The third one is student should be able to develop model of dynamic control system, and finally student can design and analyze control system using state variable methods. Alright, so this is the lecturer for this subject. We have 4 of us, me myself, the first one, and then followed by Dr. Ngui Wai Keng. For this semester, he's going to be the subject coordinator. He will responsible for all the assessment and for the coordination of the subject. The other lecturer is Dr. Azri Hizami, and the last one is Dr. Fadlur Rahman. So Dr. Fadlo and Dr. Azri will in charge, will deliver the control system. So me myself and Dr. Ngui Wai Keng will deliver about the introduction to the measurement and instrumentation. Alright, so let me go straight to the my first lecture, my first part. So I'm gonna explain about the measurement and instrumentation. Of course, from the name, from the topic, we see that there's 2 parts here, which is the first is measurement. This is about abstract, and the next one is the instrumentation. Is more to the hardware. So at the end, I hope that all of us, all the students, not only understand how to do measurement. Also, I'm expecting you to be able to develop your own instrumentation. Okay, so let me begin with the questions. How can a measurement system be used so that the engineer can easily interpret the measured data? So from this question, I'm actually asking you to do more than just measured data. I ask you to interpret the data, to go further than just looking at the value of the measurement. But this question I'll let to you until the end of the semester. So maybe some of you or all of you can have your own answer. Alright, so we did measurement almost every day, every time, every second. In fact, I myself, when I'm sitting here deliver the lecture now, I'm actually doing measurement. For example, I'm looking to the camera, so I'm looking at the light that travel through the air and come to my eyes. So when the light come in, if the light is not so bright, so I'll need to make sure that I have sufficient light so that you can see my face. So I'm doing, actually my eyes doing the measurement, and then telling the brain to act according to what I see or what I feel. For example, if I listen to some uncomfortable sound, I will ask my body to react according to the level of sound that I hear. So that's an example of measurement that us as a human beings do. Apart from that, we have a lot of things that we measure. For example, room temperature, distance we travel every day, pressure, the room pressure, environmental pressure, body weight, vibrations, velocity, accelerations, and so on. So, but why? Why we need to do a measurement? It is because we want to determine a value. We want to determine a specific value to the variables that we measure. If we measure length, we need to put a value to the length that we measure. If we measure body weight, so we need to put some value to the body weight. Of course, there is a lot of ways a lot of units that we nowadays use for measurement. But later on, we see there is actually a conversion. We can use to convert between one unit to another unit. So after determining the value, we can understand the relation between one parameter that we measure to the other parameter, and also we can understand how the variables that we measure react with time, or how it reacts with the location or space that the area that the measurement is done. So what is actually a measurement? Is an action, is the act of assigning a specific value, put a specific value into a physical variables. This is the keyword, is a physical variables. So it's actually the measurement is actually a tool to help us gaining the quantitative information, not only the qualitative. I hope that all of you can understand what is quantitative and what is qualitative. Qualitative is more abstract. For example, dark and bright, hungry, full, sweetness, bitterness. So this is a quality, is a qualitative. So if you, for example, the sweetness. So if you want to make sure that the sweetness become quantitative, we must put some numbers to the level of sweetness. For example, if we drink coffee or we drink tea, we develop the value, the sweetness value, so that all of us in the whole world can understand. If you put 10, so it's so sweet. I mean, if you took a 5, it just mid level of sweetness. So although this is the abstract, some people think that sweet is this levels, and some people feel this level. But if all of us in the world can have a convention with the level, so that we can do a measurement. For example, all of us, for example, for the length of 1 meter, everyone in the world understand that 1 meter is this length, this about this length, and then we have a standard for that. So, and then if you want to see, if you want to understand, if you want to imagine what is 10 meters, so you just multiply 1 meter into 10, so that people can have a special awareness on the space that they are into. So there is a lot of applications that that we can discuss, but I want to touch a little bit only. You can read it by yourself. For example, we do measurement. We apply the measurement system to measure the system to process. Of course, if in the factory, so the factory will do some process to manufacture something. So we need to have some kind of measurement to make sure that the process is efficient, the process is achieve the limit. The measurement system also supplied for a control of operations, and also for the simulation. I mean, for the especially for the boundary condition, for the setting, the first setting before we do simulations. Or we want to do experimental study, so we need to have a lot of measurement to measure our experiments. because again, if you can remember, measurement is one of the reason we do measurement is because of we want to understand the relations between a parameter and a parameter, this physical variables with the other physical variables. So it's about experimental. Nowadays, the measurement system become more complicated, more precise. Not only we can measure huge things, we also can measure very little things, such as little as an atom. And then the list goes on. The application of measurement system, I think I leave it to you to read further in the notes later. And then I'm going to discuss about the basic functional elements for an instrumentation. Okay, there is 4 basic functional element. Okay, first is sensing element. The second one is a signal conditioning element. The third one is signal processing element, and the fourth one is data presentation element. All these elements I will explain in step by step, starting with the first one, sensing element. And besides of basic functional element, we also have in the measurement system, you also have an auxiliary functional element. It is an option. You don't have we don't have to put the auxiliary functional elements to the measurement system, but some of applications, if you put the auxiliary, the system become more useful, or maybe it can increase the precise the level of accuracy to the system. All right, but I will explain later on the use of auxiliary in the coming slides. So if I can imagine in terms of figures, how the elements inside the measurement system is arranged. So if we have a process, so the input from the process go to the measurement system, and it will come out with the output. Usually the input is, it's not usually, but it's always, the input is a physical variables going to the measurement system, and the output will be the measured value, which is observed by the observer. Okay, as simple as a ruler. If you have a ruler itself is a measurement system. So the input is the physical length that we want to measure, and the output is what we see in the scale of your ruler. So this is the output. We can observe that one straight away. 4 basic functional elements that I discussed earlier. So we have sensing element, signal conditioning element, signal processing element, and the data presentation element. All of it is arranged in line. It should start with the sensing until the data presentation. The flow must be in that sequence. We cannot change the sequence. Alright, so if I can put these basic functional elements in terms of something that we usually see in the real world, it look like this. So we have a physical quantity. For example, we have force, velocity, pressure, displacement, temperature, flow, acceleration, strain, current, voltage, frequency, pH value, humidity, and so on. All these physical variables will be input to the our measurement system, which is starting always with the sensing or transducing elements. For the sensing element, usually we have 2 parts, which is primary sensing and secondary sensing. I will explain what is primary and secondary sensing later on when we visit on the sensing element parts. And then after you go to the sensing element, and then you go to the next stage, which is the signal conditioning. Basically, in the process of signal conditioning, there is an amplifier, a filter, an integrator, A to D converter, which is the analog to digital. This is where the analog signal is converted into a digital signal. And then after that, after the signal or the information from the sensor is conditioned, or we should say is modified to make sure that it is in a better view of, for example, if the voltage is small from the sensor, when it pass through the signal conditioning, after that the signal will be bigger. So the amplification process is done during the signal conditioning. So after signal conditioning, the signal will go to the next stage, which is some process using computer. If you're using computer or using microcontroller, it will go through the signal processing element, and after that we go to the data presentation, either in term of display through a large monitor, or it just showing the scale, such as the ruler that I discussed earlier. What kind of display that usually we have? Terminal, recording monitor, analog indicator display, data logger, graphical display, output, printed output, also some sort of display. So the first part in the basic functional elements is the sensing element. So this is the first surface, in layman word, is the first surface that touching the physical variables, parts that acquire the signal. The example of sensors is, for example, is the thermocouple, which is it sends the change of temperature and convert it into a change of voltage. And the other example that I listed here is the strain gauge. It measure the change of a strain and give information in terms of the resistance change, and later on converted into voltage. So this is two examples of sensing elements that we frequently use in mechanical engineering. The mechanical, the sensing element that mechanical base or give the mechanical output, for example, the changes of the deformation of structures, the spring movement, the diaphragm movement, all these are mechanical output sensing element. This is we call it a primary sensing element. For sensors that have primary and secondary elements, the mechanical parts, the mechanical output sensing element is a primary sensing element. Not all the sensors can be considered a primary or secondary, because some of sensors only have one type of sensing element only. The secondary sensing element is electrical based output, or electrical that the sensing parts that give the electrical output. Usually this secondary sensing element is in the sensor that need to be connected to the computer or microcontrollers or any other digital device. This is a simple example of a measurement device that has simple basic functional element, which is only have sensing element and a display element. I already put a label here there, so you can see where's the sensing element part and where's the data presentation part, and in the middle is the signal conditioning. For this kind of sensor, it's only have one primary sensing element. There's no secondary element, and also there is no data processing element or a signal processing element, because this kind of sensor only mechanical based sensor. When we talk about sensing element, there is a list of desirable characteristics for a transistor element. There is a lot of list that is a very long list for desirable characteristic, but I will touch only a bit that I think is very important. because these characteristics differentiate between accurate sensor, expensive sensor, and cheap sensor, very precise sensor. So this depend on the desirable characteristic that a certain sensor have. Okay, so the first one I want to discuss here is the sensor should be it only recognize a desired signal, desired input. For example, if the sensor is intentionally to measure strain, so the only strain that the sensor can measure. If you want to look for precise, accurate sensors, go for the sensors that have only accurate, sensitive to only one desired, or sensitive, sensitive to the desired input only. And then the other characteristic that is good for a sensor is the sensor should not alter the event to be measured or the state of physical variables to be measured. For example, if you want to measure temperature, we put a sensor. That sensor cannot increase the temperature surrounding the area that we want to measure the temperature. Same goes with the pressure. We try to measure pressure, but the transducer or the sensor at the same time increase the temperature, the pressure. So this kind of sensor is not really good, and then it may cause a lot of noise, and it may give inaccurate information to us. And nowadays a lot of equipment is in digitized equipment. So preferable, we want a sensor to have electrical output. Okay, electrical output based sensor, because the electrical output can be connected to the microcontrollers for better control system, and also we can connect to the computer. The sensor also need to have a good accuracy and a good repeatability to the measurement, good linearity, adequate frequency response, especially for the dynamic measurement. And then it also, we want it to measure in real time. There is no delay when doing the measurement. So the next basic functional element that's very important is the signal conditioning elements. Basically, most of the measurement device or measurement system need to have a conditioning element, because the input that coming into the device or the system, the measurement system, usually the input is not in a good way, in its good form. Usually the signal is embedded with noise, and also sometimes the signal is low in the amplitude. With the signal conditioning, either we can increase, amplify the input, or we can filter the noise. And also, if you want to use a computer based system, or if you want to use a microcontroller, the signal that we acquired after the sensor element, we need to convert it into a digital signal. So the conversion from analog signal to digital signal, we need to have A to D converter. If the sensor is mechanical based, the signal conditioning element can be a set of gears, a set of springs that can amplify the amplitude. So it depends on the design by the engineers who design the measurement system. So this is the example of signal conditioning elements: amplifier, filter to remove some kind of automatic signal, deflection bridge that converts impedance change into a voltage change, oscillator converts an impedance change into variable frequency voltage. So there is a lot of conditioning element, depends on the sensor that we have. Either it's a mechanical based sensor or it's electrical based sensor. Three things that are very important to be discussed theoretically in the signal conditioning element, which is the amplification, filtration, and analog to digital converter. The third basic functional element that very important is the signal processing element. This is a critical part, whereby the signal from the sensor, the sensing element, then go to the signal conditioning element. We process it, we make sure the signal is clean, we make sure that signal have sufficient amplitude, and then it goes to the signal processing element, whereby the signal is being processed to get whatever information that we need. So the final parts of the basic functional element is the data presentation element. I have shown you in the previous slides there is a lot of example for data presentation elements, and I will not go further on this one because it's very easy. You can see the examples, a lot of examples available. I have discussed a lot of before. So we have seen the details of each basic functional element for measurement device. So now we want to see how that basic functional is combined together to develop a complete measurement device or measurement system. So look at to this slide. There is an example of there is 4 examples of measurement that we want to develop. We will design the measurement device, but first we have to block the component. Suppose that the components is being a compulsory parts in the measurement device. For example, if you see, if you look at the first example, which is to measure the temperature. So we have to know that the temperature must have sensing device or sensing elements, the signal conditioning elements, signal processing elements, and data presentation elements. So and then we plan the flow of the signal. Is it we need a signal conditioning, or did we need the signal processing element? So if we need each one of those, so we have to plan what is the component for the signal conditioning or the component for the signal processing. For this kind of example, we want the signal to be in computer, I mean digital result. So first we have a thermocouple to convert the physical variables, the temperature, into voltage reading, which is then we have to amplify the signal if the signal is low, or we have to make sure there is no noise, or for this case we can say that the noise is come from the small changes of the temperature due to the environmental change. So we can add on methods how to remove this noise. For example, for this case we put auto reference junction compensation, which is we try to eliminate the effect of temperature environment temperature to the measurement, and then we amplify using amplifier, and then after the signal conditioning, the signal will go to the signal processing, but before that it have to pass through the analog to digital converter, and then the computer will understand the signal, because after A to D the signal will be in digital, and then after processing whatever processing that we want, and then the signal we present it through the display. The display you can choose according to what we have discussed before. That is the first example, which is using the for temperature measurement. There is a lot of example. There's 3 more examples. You can have a look, but I want to show you. This is the example, the physical example, how a measurement device we can block. Before this, the slide before is without the physical measurement device. We have only a planning how to design the measurement system or measurement device. Starting with a block, we plan the block, and then after that we can design whatever we can fabricate whatever sensor that we want. But now, if we have a drawing of sensor or device, measurement device, how can we block in that device which one is sensor element, which one is signal conditioning element, and which one is data presentation element? For this example of Borden tube, we start with the sensing element. So the sensing element is the Borden tube itself, which is it convert the pressure that comes into Borden tube, it convert into a movement of the Borden tube itself, and later on the movement will move the lever, which have a tooth sector, which the tooth sector is connected to the gearing parts that is connected with the pointer that showing the scale, showing the indication on the scale for the pressure. So if we block into block diagram, the Borden tube is going to become the transducer element, and then with that small changes, the small changes of the Borden tube due to pressure, we can amplify the deformation of the Borden tube by using the gear and lever mechanism. So this is stated here in the slide, which is so if you can see and this in this part, signal conditioning element, which we have or the lever, the gearing. So then the signal go after the amplified signal, it go to the display, where this display we shown by is the display is by the pointer and the scale. So this is a component of the presentation element. So when we block this device into the block diagram, if we have new improvement to the sensor in the future, we can choose which part to modify. Either we want to modify the display element, or we want to modify the signal conditioning element, or we want to modify the transducer element. So note that this one is a mechanical based sensor. So if you want to convert a mechanical based sensor into an electrical based sensor, so basically the one that involved here for the modification is, I think, is the after the sensor part, which is we add on. Okay, let me refer to the next slide. Look at the part sensing element part. We add on the secondary element. The secondary sensing element, which convert the physical deformation of the Borden tube into a voltage reading, which later on the voltage reading can be manipulated the value to amplify or to filter the noise. There is no more mechanical parts involved. There's no more lever. There's no more gearing mechanism to condition the signal to make it better. But now is all involved is all electrical components. So the signal go to the signal conditioning element, which is the electrical components. We have a voltage amplifier, mechanical filter, electrical filter. Sorry, not mechanical filter, but it's electrical filter. And then after that, the signal straight away go to the digital voltmeter. This one, if we convert the mechanical based sensor into electrical based sensor, it will allow us to do real-time big data collection. Usually this kind of things, the electrical based sensor can be used for structural health monitoring in plants, and also in vehicle, and many modern structure for monitoring now, or many modern equipments, many modern vehicles we frequently use sensor which connected with the electrical based sensor. Alright, so there's a lot of more there's more example here in the slide, so I hope that you can have a look. Also, I stated in the slide, or I stated in the notes, the principle of operation for physical variables, to measure physical variables. Let's depending on the principle of operation, we can draw the block diagram for the measurement system. I go through this one. You have a look in the slide, and there is an exercise which is I want you to do. I want you to practice your knowledge that we have learned in the previous slide for this lecture, which is I give 3 examples of physical sensor. Either it is mechanical base and electrical base. So you go have a look and try to draw the block diagram for each of measurement device or measurement system. For example, have a look to the first one is the diaphragm type liquid level gauge. This is diaphragm type liquid level, and then this one is a spring. I think it is a spring balance with electrical readout, and last one is fuel level gauge, floating fuel level gauge. So this is a floating fuel level gauge. So you have look. I think it's fully mechanical because we have gearing system here. So I leave it to you. These 3 example exercise. You do it, and then we will discuss. So we will discuss face to face about this exercise. So until now, so thank you very much for your attention. So I finished this part. So after this, we go to the next topic, which is the measurement concept. The measurement concept. Thank you.